Hi guys, now we'll solve today's lead code problem of the day, which is left and right sum differences. This problem we'll solve with two approaches. In first approach, we'll take extra like space complexity, but in second approach, we'll solve in constant space complexity. So the question is, we are given zero indexed integer array nums whose size is n. Now two arrays are defined, left sum and right sum. Left sum of I is defined as sum of elements to the left of the index I in array nums. And if there is no such element, left sum of I is 0. Like if this is the nums, if we want left sum of 2, then it is defined as sum of all the elements whose index is less than 2 in nums array. So like left sum of 2 will be 14. We can see here also. Similarly, right sum is defined as sum of all the elements to the right of the index I in the array nums. And if there is no such element, then right sum of I is 0. So like here, right sum is defined as in nums how many elements are right to that index. Like if we see right sum of 1, it will be two elements are there, no, so it should be 11. So right sum of 1 is 11, and for the last element there is nothing in the right, so for that we should take 0. Now we have to return an integer array answer of size n, where answer of I is absolute of left sum of I minus right sum of I. So we have to return one answer array which should set for in which all the in elements should satisfy this condition. So here, let's see the example. This is the nums array. Now, if we want to find left sum array, which will be for this element, there is nothing in the left, so 0. For this, 10 is in the left, so 10. For this, two elements are there, their sum is 14, so 14. And for this, three elements are there, their sum is 22, so 22. Similarly, we can find the right sum. After that, we'll just apply the condition for every index. Answer of I is equal to absolute of left sum of I minus right sum of I. Like for zeroth index, left sum is 0 but right is 15, so absolute of 0 minus 15, then 10 minus 11, 14 minus 3, 22 minus 0, and we'll get this our answer. So first we'll see the brute force approach. So it is very simple. The question says we need to find left sum array, right sum array, then just apply this condition. So simply in this approach also, we'll take one left sum array, right sum array, then we'll traverse from first index till n minus 1 index, and we'll compute the left sum array and right sum array. So for ith index, left sum of I contains the sum of all elements from index 0 to I minus 1 in nums, and this left sum of I minus 1 contains sum of all elements from 0 to I minus 2th index. We have sum of all elements till I minus 2th index. We'll add the nums of I minus 1, then we'll get left sum of I. Similarly, right sum we want to calculate. So since we want to calculate from last, instead of taking another loop, we are just trying to calculate in this only. So this I have written as n minus 1 minus I. So like if I is 1, then this will represent as n minus 2. I is, if 2, then it will represent n minus 3th index, and so on. For that, like this right sum contains all the elements, which sum of all the elements which are right to this index. So this n minus I contains sum of all the elements which are right of n minus I. So like this contains all sum of all elements from n minus I plus 1 to n minus 1. We will add n minus ith element, then we'll get this right sum of n minus 1 minus I. Now after these all the iterations in this loop, we will get the left sum array and right sum array. Then we can simply like take the answer vector, and we can simply traverse from 0th index till n minus 1th index and apply this condition and get the answer, vector filled with the correct values. After all the iterations are done, our answer vector will contain whatever is asked, then we'll return the answer. So in this, if we see, like, this loop goes from 1 to n minus 1, this also goes 1 to n minus 1, so both are like we go of n only, so overall time complexity is we go of n. But here we are using extra, like this left sum vector and right sum vector, so it is taking space complexity also as we go of n. So now we'll see second approach where we are using constant space complexity. Like we are using only this answer vector additional, but in the question it is asked, so it will not be calculated as our additional space complexity. So overall in this approach our space complexity will be we go constant space complexity. So what we are doing is we are taking two variables, one is left sum and one is right sum, and what they'll contain initially, left sum is 0, but as we will traverse from left to right, we'll explore the elements, so we'll keep on adding the elements to the left sum, so that we are sure that for ith index left sum contains sum of all the elements from 0 to I minus 1, and in the first loop our answer of I will contain the left sum. And once this loop all the iterations are done, in the second loop this answer of I already contains the left sum, and in the right sum we are already computing as we are exploring the elements, so we have right sum also. We can simply apply that condition of left sum minus right sum, and we can store in our answer vector and finally return the answer. So in this way we have not used any additional space, and in this we are able to solve this question by using time complexity of big O of n, but with constant space complexity. Thank you.